Well, hello everybody. I hope everybody is staying safe throughout the storm. I am going to record today's planned didactic in order to try to stay on course for the semester. First time I've done anything like this, so maybe a little rough around the edges, but I'll give it my best shot. We're talking about population and sample techniques today. Here are the objectives. We're going to explore some different theories of the individual or human beings. Then we're going to define a few operational concepts related to population and sample size. We're going to introduce a few sampling techniques and then understand how each of these selection processes can introduce bias or affect study results. A little disclaimer, we're going to talk about a few theories, and those aren't equated with the truth, but theories or models are better understood as metaphors to assist with the understanding phenomenon. So I just wanted to lay that out there because the first half of this talk is going to be a little more esoteric before we get to the technical stuff. Along that lines, in order to generate useful concepts for populations or groups, we're going to start with concepts about individuals. In terms of individuals, this probably speaks more to my own background, but maybe to some of the students. I have a clinical background in medicine, and really our training and the majority of what we do in the clinic is based on a biomedical model. And is based on treating individuals, not necessarily populations. Now that's really important because the patient in front of you is generally singular, and dealing with that patient is the focus of practical medicine, and it's also important for generating research questions and inquiries which usually come from patients that affect us greatly. The biomedical model is efficient by really focusing on biologic concepts of disease and focusing on the individual in front of you. It limits the scope of what you talk about into a short individual patient encounter, which is often 15, 20, 40 minutes. And generally this is a tradition in at least Western medical training as a popular concept. In this model, generally health is equated with the absence of disease. Health is also determined by an expert physician in an enclosed encounter. And health is often defined as the normal for a population. And this is in contrast with some others where health is interactively defined between a patient and a doctor or a group of people. Works really well for relatively simple linear models of causation, and I'm going to show an example in a minute. Physical injury, infectious diseases, simple genetic polymorphism conditions. The biomedical model works very well in these situations in terms of explaining causal factors of disease. But as I've said in the disclaimer, all models or theories are not perfect. The biomedical tends to be reductionist. It oversimplifies a web of causation, which we're also going to show examples of, which is really prominent in a lot of the chronic multifactorial illnesses that we see in today's society. It's reductionist in the sense that it de-emphasizes the social or population aspects of disease. And then it may confuse causes of population incidence with causes of high individual risk for disease. I don't have time to discuss this important concept today, but I will send out this article, Rose 1985, which is a really fantastic read that goes over this in detail. So here is what we see as a example of a biomedical model This type of graph is called a diacyclic graph, or DAG, where we see arrows connecting causal factors. Usually there are different symbols here. I believe Mitch Klein class goes over this, so I won't go over it in too much detail. But in general, we see, let's see, social factors are here, but they tend to be somewhat de-emphasized. They lead to individual behavioral patterns, and we see a final biologic cause of disease. So everything sort of filters through a linear system or a linear causal pattern, creating a biologic phenotype which can lead to a disease entity, de-emphasizing some of the complexity that we'll talk about in the next model. So on to ecosocial theory. This expands on the biopsychosocial model, which I don't have time to go into. It was initially laid out by Nancy Krieger in 1994. She is a Harvard epidemiologist. It has 4 core tenets that we're going to go to separately. Starting with embodiment, this is the first tenet of ecosocial theory. So human beings literally incorporate biologically in societal and ecologic context the material and social world in which they live in. Now, this isn't really a complex concept. Essentially, what the diagram is showing here is that this physical environment, other parts of the environment, and our behavior are all incorporated physically into the human being in terms of altering gene expression and also altering physical human states to produce the final phenotype. This is not all inclusive, but I included several different environments, the microbiome being sort of a hot topic environment today. Second tenet, so there are pathways of this embodiment. They are diverse, concurrent, and interacting. Here's a couple of pathways here: adverse exposure to social and economic deprivation, exogenous hazards, social trauma, targeted marketing of harmful or helpful commodities, healthcare systems, and ecosystems. Again, here are a couple examples: toxic substance, pathogens, microbiome, hazardous conditions, which is relevant in our current hurricane around us, social trauma. Again, these don't just affect the individual in sort of the direct effects, but also in terms of indirect effects of affecting potentially the behaviors and the access to commodities or things that influence more directly health. And again, I put here alcohol, illicit drugs, just a few examples. Adding to our diagram, I've now added these bidirectional arrows to really demonstrate that through all of these environments there are interaction or concurrent simultaneous interaction, that they all are each interacting with each other to affect the individual. Not so much part of ecosocial theory, but another theory, fundamental cause theory, where they label socioeconomic status, or SES, as a cause of causes, a fundamental cause. SES can be a cause of our physical environment. To take the hurricane example that we are in, SES can affect the construction of the housing folks live in or the construction of the housing around them. The nearness to water. Again, you see how a low SES or high SES can affect that in different ways, which can then eventually lead to downstream effects, a new interaction with the environment, the storm, and now there are different outcomes affecting the individual. So SES is a quote-unquote a fundamental or cause of causes. So many pathways, diverse, simultaneous, interacting. Now on to the third tenet, the cumulative interplay of exposure, susceptibility, and resistance across the life course. So now we complicate the model even more, where we don't just take the interacting environment and society with the individual, but we now look at how the timing of these are important to the final phenotypic expression of an individual or the embodiment of the individual. So I put here in a simplistic way, we're born with a certain set of genes, but there is a life course throughout which there are certain very sensitive periods where the environment in the embryo can have effects downstream into adulthood, and potentially that same environment would have different or diminished effects as a child or during adulthood. So again, there is accumulation of exposures, the timing during the life course is important, and this all again interacts with the individual's genes to affect expression and ultimate phenotype. So it's not just gene frequency, it's the expression that ultimately leads to the adult or whatever individual phenotype we are addressing. The final tenet is accountability and agency. This isn't so much important for this class, but I include it here for completeness. And the idea here is that it's not just the individual behavior and choices that are completely accountable for the ultimate phenotype, but it's also social systems, governments, societies, communities that are accountable agents of disease patterns. And the original theory did include a call to researchers as a responsibility for these disparities. So we look back at a breast cancer model now with a more eco-social theory approach, where now we see a much more complicated web of causation rather than linear, with several bi-directional arrows in terms of the different events that are interacting with each other simultaneously. We see some important concepts that are not just about exposure, but about the timing of exposure across the life course, the age at first, early termination of pregnancy, for example. We see again the SES or socioeconomic status as a cause of causes or a fundamental cause here. We see not just the life course of the individual, but also in this technological level here in the upper left, sort of where that individual is situated in and the technological advancements of their society or what's available to them also affects how those exposures play out. These all interact with the individual susceptibility, or conversely the individual resistance to exposures, ultimately ending in a potential phenotype of breast cancer or not. So again, essentially just drawing a more complicated theoretical explanation of human patterns and phenotypes. So take a breath here and ask ourselves, so who cares? So I'm going to read from the original designer of this theory, Nancy Krieger again. The point is not that every study can or should attempt to measure every specified pathway at every level and at all relevant spatio-temporal scales, obviously impossible to do, but rather that systematic theorizing about what is or is not measured and how can aid in the interpretation of study findings. And I would like to also say can aid in the development of appropriate study design in the front end. Again, this situates in a broader context, a broader societal context in investigations motivating theories, hypotheses, methods of analysis, and interpretations of findings to improve the likelihood of being better positioned to understand and convey the meanings and limitation of our study results and explanations for population patterns of health, disease, and well-being. So essentially, the whole point of bringing this up was to help us as we're designing studies, or conversely interpreting studies, to understand the enormous amount of input into each individual participating in that study, how it can create massive amounts of variation in associations, and really helps us again understand that the complexities of that variation, so we can better help to understand it and measure it. Okay, let's take a break there.